Okay, in 8.5, we're going to be adding and subtracting fractions. It's really easy when the denominators are the same. So for example, here it's 3 over 4x plus 5 over 4x. You just add the numerators together to get 8 over 4x. It's much different when the denominators are different. Like here it's 4x and here it's 7. So just like you used to do when adding and subtracting fractions, you have to make the denominators the same. So to do that, you have to find the least common denominator. And what you're really going to do is just say, how can we, combine those so that it makes the same denominator? So here we have 4x, here we have 7. If it was just 4 and 7, we would need to change both denominators to be 28. But here it's x as well. So on the right, we need to multiply by 4x over 4x. And on the left, we're going to multiply by 7 over 7. To change this denominator to be 28x, to change this denominator to be 28x. On the top we have 7 times 3 is 21. And over here we have 1 times 4 to give 4x. Now we can subtract these two. So 21 minus 4x all over 28x. 21 minus 4x. We cannot combine those, different terms, over 28x. Alright, let's walk through a slightly harder example. X over x squared minus x minus 12 plus 5 over 12x minus 48. So in this one, it's a little less clear like what the denominator should be. So first we're going to factor it. It's going to make it more clear. So we'll factor the bottom. So x over x looks like minus 4, x minus 4, and x plus 3. That should work. And on the right side, we have 5 over 12 times x minus 4. So now we're just going to compare the denominators. They already both have x minus 4, so that's fine as it is. However, this equation on the right needs an x plus 3. So I'm going to multiply the top and bottom by an x plus 3. And this equation on the left needs a 12. So this one needs x plus 3, this one needs a 12. So I'm going to multiply by 12. Not 21, but 12. 12 over 12. Okay. So once we do that, we have 12x over 12 times x minus 4, x plus 3, plus 5 times x plus 3, all over 12, x minus 4, x minus 3. And now we have the denominators that are exactly the same, and that's really the goal of this. So if what you do doesn't give you the same denominators, then you need to reevaluate what you did and maybe try something else. So the next step is going to be, I guess, just multiplying this 5 through. So we have 5x plus 15. Now we're just going to add the numerators to get 17x. 12x plus 5x is 17x plus 15 all over this common denominator that we have, 12 times x minus 4 times x minus 3. And I'm not really sure if they're going to have you multiply this out or not on the denominator. For the problems that I've seen in the book, it's not going to make you. So this would be an appropriate answer. The last part of this section is going to be talking about complex fractions. So this is one big fraction, 5 over x plus 4 over 1 over x plus 4 plus 2 over x. And we're just going to simplify this down. So in order to do this, we're looking at all the denominators. So x plus 4, and x. And if we want to find the least common denominator, we're just asking ourselves, what do we need to make them all be so that the denominator is the same? So we know the least common denominator is x times x plus 4. Because some of them have x plus 4, some of them have x, but some of them need the x, some of them need the x plus 4. So what we're going to do is multiply the top and the bottom by x times x plus 4. Because some of them need an x on the bottom, like these x plus 4s don't have it. Some of them need an x plus 4. This one just has an x. So we're going to multiply each term by x. So the top by x times x plus 4 and the bottom by x times x plus 4. So we're going to think about what is this times x plus 4. Well, I'm going to write it over here. You don't have to do this. I'm just going to write it to make it a little simple. So remember, this is on the top. So the x plus 4's cancel out, and it's really just 5 times x, which gives us 5x. We do the same thing on the bottom. Multiply it times x plus 4. Right? And the x plus 4's cancel out. This first one is just x. Over here, the x's cancel out. So this one has to be multiplied times x plus 4. 2 times x plus 4, which is so plus 2 times x plus 4. Then we're just going to simplify 5x over x plus 2x plus 8, 5x over 3x plus 8. One more example. So we're going to first look and see what the least common denominator is going to be. Like this one has an x minus 3, but these other two are x plus 5. So we know the least common denominator is x minus 3 times x plus 5. Because one of them needs x plus 5, the other two need the x minus 3. And of course it's over x minus 3 times x plus 5. And then we're just going to multiply it out. So the top gets multiplied by this. Each of the bottom two, because they're separate terms, gets multiplied by this. So I'm going to grab a different color here. So let's do the top first. So 3 over x plus 5 times x minus 3x plus 5. These x minus 5s will cancel, and it's really just 3 times x minus 3 on the top. 3 times x minus 3. On the bottom, let's check it out. For the first one, the x minus 3 and x minus 3 will cancel, so we get 2 times x plus 5, plus the second one, the x minus 5's cancel, and it's just the x minus 3. 1 times x minus 3 is x minus 3. Then I'm just going to simplify everything. 3x minus 9 over 2x plus 10 plus x minus 3. So we get 3, combine the x's to get 3x minus 7 on the bottom. So our answer is 3x minus 9 over 3x minus 7.